Hi everyone. In this video, we are going to see the concept of voltage equation of a DC generator. Voltage equation of a DC generator. So what is voltage? Voltage is a kind of pressure, right? But in DC motor, there exists a concept called back EMF. There exists a concept called back EMF, which is represented by EB, back EMF. So we have seen this back EMF in the earlier video, right? This back EMF is nothing but generated voltage in the motor or induced voltage in the motor irrespective of the supply voltage, or it will oppose the supply voltage. Back EMF is a EMF or induced EMF which will oppose the supply voltage or input voltage. This is one of the back EMF. Now let's have the expression of voltage expression or voltage equation with the help of the equivalent diagram. So this is the motor, this is the motor, this is the brush assembly. Now this is excited by the both field winding and armature winding of a motor is excited by DC supply or by external supply voltage, and the polarity is plus and minus, and the current flowing from the supply is IA, which goes to the armature. This A and AA. Here this is the input supply given to the armature for motoring action, but after motoring action, after the excitation of both the coils, this will create, the armature conductors will create an induced EMF which is known as back EMF EB, right? It will always be always in opposite direction to the opposite direction to the input supply, right? So the current is flowing towards the armature conductor, but after a particular time, after achieving the particular speed or rated speed, the motor tries to induce an EMF, and it is denoted by EB, and the current from this opposes the input current from the supply voltage, right? So this is known as back EMF. Now from this we can derive the voltage equation. So V is equal to this is the V, this is V, right? This is V. V is the input voltage. V is equal to EB back EMF plus the drop, the input supply drop is equal to, we are going to calculate our voltage, total voltage, and its related parameters, right? Related drops, right? The V, for example, if you supply 10 volt, this 10 volt is consumed by this brush as well as armature conductor, armature resistance drop, then this back EMF, right? So we are going to add the input voltage, we are going to check, or we are going to equate the input is equal to output with losses, right? So V is input voltage and EB is the back EMF produced, and the voltage drop across the armature conductor is IA into RA, plus there is some brush drop, or there will be some brush drop, so we are taking into account. So V is equal to EB plus this IA RA is nothing but VA, voltage across the armature. Voltage drop across the armature is represented by IA into RA, right? Then this is the drop across the brush, right? So this is the voltage expression for DC motor, but the drop across the brush will be very negligible, right? Very negligible. So we can exclude this brush drop, and the expression for voltage is, input voltage is EB, V is equal to EB plus IA RA alone. So we have excluded the brush drop, right? So this is the voltage equation of a DC motor, IA RA, right? Now, if we want to calculate the value of IA, so IA is equal to V minus EB divided by V minus divided by RA. So we can also calculate armature current IA from the voltage expression, right? Let me solve a step after or before this. I have one step. I will solve this here. From this IA RA is equal to V minus EB, right? So I am just bringing this EB to this side, right? So it will become minus, plus will become minus. So now RA, I am taking RA into denominator, so to find IA, so IA is equal to V minus EB divided by RA. This is the expression I got here, right? So this is the voltage and armature current expressions for DC motor. Thank you.